Howdy. You can buy for €2 this kind of birch logs, and someone was a little bit cutting with a mortar saw into them. They are cheaper, more than a half cheaper than usually, and from Estonia. And I claim that there is quite a bunch of forest here in Finland. Very interesting. That's an own log. And here's the heart of the tree. And it's a little bit hard to see. I took it aside. I won't burn that. You can see how it's spiraling. And I tried to somehow capture that. If you would take it from here, it's almost 180 degrees what it turns. It's a little bit hard to see in the picture. Here you can see the heart, which goes through the whole thing. That's the other side, obviously. And here you can see how it's spiraling. And that's somehow 90 degrees from that. In a way, how to draw that now. 90 degrees. And in a way, I don't know, it looks like that this would spin almost 180 degrees. And I thought that's very interesting. I don't know if anyone else finds this interesting, but I thought it's very interesting. And I somehow tried to dry it up and smoothen it out that it's visible better, but I still don't know yet how and when. So that's still a project. But I thought that's very interesting. And here, once again, same. Yesterday I just was about to bring out some compost, and then I noticed that there's some chickens were outside. One I already got inside, and then I thought that's maybe fun to watch. catching chickens with the help of our little cat. And it's not that, one went in there all by itself. And the thing is, there's like weasels, foxes, bears, maybe even wolves out here. So it's probably better for the chicken if they stay inside. It's not that. But they have plenty of room there. Thanks to the cat for helping. Yeah, doing things, random stuff. That's from yesterday. I could take a glimpse of what's above the lower clouds here. And it looked very interesting. It was the day before the storm. And this is how I can watch Windy from a computer. You can zoom out much further, so I did. I made a video with my phone of my computer. And I think the pattern is rather interesting. Maybe I should use another color. Let's use this pink thing. That's very interesting. That somehow here we have this very low or rather strong weather system in Florida and southern states in America, which seems to be connected all the way to here. And from here, Labrador Sea, it's pushing down. Let's see if it will reach once the equator still. Would be very interesting. Yeah, it would be really cool to have the possibility to zoom out as far as you can do with a computer, with a phone. But anyway, use what you got. Make the best of it. It was rainy, it was sunny, and there was, from this very little window, you could see a rainbow. So I went outside, and the rainbow was still there. And there's actually Oh, no, it's maybe not visible on this. Actually, it's here. I don't know. For those who can see, here's the second one, really faint. Here it's maybe visible. Let's try to enhance a little bit the colors. Saturation. Yeah, that's very colorful. Yeah. But anyway, wrong button. Discard. So there's just this other one beside it. And then I noticed, as those clouds were moving very fast. Yeah, that's another shot of it. Here you can see two rainbows. Maybe there's even a third one, I don't know. And at that time I took the picture, it wasn't really windy yet. Now it's very windy. And I found it fascinating that there's a rainbow, like in a way cut in half. Here we don't have clouds, and here we have clouds. That's interesting. Yes, I think I leave it here. Got stuff to do. And there's so many things going on earthquake wise and all kinds of things. Actually, now I just remembered. I read an article today. Let's see if I find it. And I haven't read it yet through, but phys.org, 23 hours ago. Physics, general physics. Now listen to that. That's a title. Like, I assume most of the people involved in making this article and whatever thing, they are highly educated adults. One of the greatest damn mysteries of physics. They're swearing in the title. In a way, this talks about the desperateness. The most precise astronomical test of electromagnetism yet. Electromagnetism. There's an awkward, irksome problem with our understanding of nature's laws, which physicists have been trying to explain for decades. It's about electromagnetism, the law and how atoms and light interact, which explains everything from why you don't fall through the floor to why the sky is blue to why we have clouds in the sky. Our theory of electromagnetism is arguably the best physical theory humans have ever made. They don't really talk about what they have been figuring out, I think. But anyway. But these are very big words. But it has no answer for why electromagnetism is as strong as it is. Maybe it's just a rule of nature. This is how nature works. It's maybe that simple. Because it's the only way how to transport information and energy at the same time. Nature is quite clever, you know. Only experiments can tell you electromagnetism's strength, which is measured by a number called alpha, aka alpha, or the fine structure constant. Yes, I don't know. I haven't heard the fine structure constant ever. I won't dive into that. I refer to Walt Thornhill, Anthony Perrat, Ralph Jurgens, Thunderbolts Project, Suspicious Observers, Michael Claridge, Dave Talbot, Dr. Scott, Michael Steinbacher, Tesla, Alphen, Birkeland. But anyway, The American physicist Richard Feynman, who helped come up with a theory, called this one of the greatest damn mysteries of physics, and urged physicists to put this number up on their wall and worry about it. Nature doesn't use numbers. Richard Feynman. But anyway, I'm not a professional. He is. In a research just published in Science, we decided to test whether alpha is the same in different places within our galaxy by studying stars that are almost identical twins of our Sun. If alpha is different in different places, it might help us find the ultimate theory, not just of electromagnetism, but of all nature's laws together. The theory of everything. Electric universe. EU, electric universe. It's totally scalable. From the tiniest part to galactical scales. SAM, S-A-M, structured atom model. We want to break our favorite theory. Physicists really want one thing. Yeah, a good salary. And fame, probably. But the salary. A situation where our current understanding of physics breaks down. New physics! A signal that cannot be explained by current theories, a signpost for the theory of everything. To find it, they might wait deep underground in a gold mine for particles of dark matter to collide with a special crystal. Or they might carefully tend the world's best atomic clocks for years to see if they tell slightly different time. Or smash protons together at nearly the speed of light in the 27-kilometer ring of the Large Hadron Collider LHC. Yeah, the chickens, they are watching. Very intense. I'm talking to the chickens now. Listening? Yeah, they are. The trouble is, it's hard to know where to look. Check out the Thunderbolts Project YouTube channel. I could send it. I'll probably send this to this guy. Let's see. There's... if a random dude like me is able to find the information and is able to grasp what it means, is able to understand how wrong the modern paradigm of basically all sciences is wrong. Timelines are totally wrong. Geology is totally wrong. All these kinds. Climate change, human-made climate change, all wrong. How they don't know. Of course, we look in laboratories on Earth where it's the SAFIRE project, where it's easiest to search thoroughly and most precisely. But that's a bit like the drunk only searching for lost keys under a lamppost, when actually he might have lost them on the other side of this road, somewhere in a dark corner. Science tells us we only use probably 4% of our brain. The rest is just useless garbage to fill our skull in order to keep the head on. Modern science tells us 94 or 6% of space is empty. There's nothing. They are so wrong. I would say maybe. We can take the similar numbers as they claim that the universe is empty or our brain is unused. The same percentage numbers, let's say it's 95%. One could probably make a conclusion that 95% of the things we got taught are wrong. It would fit in the paradigm, at least numerically. But anyway, they are still in the dark corner. Let's shed some light. Wake them up. Let's get free. Stars are terrible, but sometimes terribly similar. We decided to look beyond Earth, beyond our solar system, to see if stars which are nearly identical twins of our Sun produce the same rainbow of colors. Atoms The atmospheres of stars absorb the light of the light struggling outwards from the nuclear furnaces in their cores. Meh. There is no such thing as nuclear furnaces in their cores. The sun is not a nuclear power reactor. Only certain colors are absorbed, leaving dark lines in the rainbow. These absorbed colors are determined by alpha. So measuring the dark lines very carefully also lets us measure alpha. Yeah, they try to get out of the dark, and what they figure out, let's measure the dark lines. Yeah. Double layers, probably. These are those little anode tufts. It's very cool. The problem is the atmosphere of stars are moving. No, it's not a problem. It's how nature works. Everything is dynamic. Boiling, spinning, looping, burping, and this shifts the lines. The shifts spoil any comparison with the same lines in laboratories on Earth, and hence any chance of measuring alpha. Stars, it seems, are terrible places to test electromagnetism. Oh man, how much wrong can they go? That's amazing. That's really amazing. Stars, it seems, are terrible places to test electromagnetism. Stars form on strings on cosmological Birkeland currents. They are pinched into matter. But we wondered if you find stars that are very similar twins of each other, maybe their dark, absorbed colors are similar as well. So instead of comparing stars to laboratories on Earth, we compare twins of our sun to each other. A new test with solar twins, a team of student, postdoctoral, and senior researchers at Swinburne University of Technology at the University in New South Wales measured the spacing between pairs of absorption lines in our sun and 16 solar twins, stars almost indistinguishable from our sun. The rainbows from these stars were observed on the 3.6 meter European Southern Observatory ESO telescope in Chile. While not the largest telescope in the world, the light it collects is fed into probably the best controlled, best understood spectrograph, HARPS. HARPS? Is this HARP? If it would be basic HARP, it would have two A's. Yeah. The chickens are wondering about a similar thing. This separates the light into its colors, revealing the detailed pattern of dark lines. HARP spends much of its time observing sun-like stars to search for planets. Handily, this provided a treasure trove of exactly the data we needed. From these exquisite spectra, we have shown that alpha was the same in the 17 solar twins to an astonishing precision, just 50 parts per million. That's like comparing your height to the circumference of Earth. It's the most precise astronomical test of alpha ever performed. Unfortunately, our new measurements didn't break our favorite story. But the stars we've studied are relatively nearby, only up to 160 light years away. Yeah. What's next? We've recently identified new solar twins much further away, about halfway to the center of our Milky Way galaxy. In this region, there should be much higher concentration of dark matter. Yeah, because they think there's a black hole. They are searching for dark lines and dark matter still. An elusive substance astronomers believe lurks throughout the galaxy and beyond. Like alpha, we know precious little about dark matter. And some theoretical physicists suggest the inner parts of our galaxy might be just the dark corner we should search for connections between these two damn mysteries of physics. If we can observe these much more distant suns with the largest optical telescopes, maybe we'll find the keys to the universe. No. No, you won't. Is there any name? I will send this one person. I tell it now. I don't know when I can make it. But is there any name? Richard Feynman. So now, by here, I announce. I write him. I write Richard Feynman. And I will tell you when I wrote it. And I probably... No, I don't know. I try to save people's private sphere, so I just maybe announce now that I will write to him. And I will tell you when I wrote to him, and I will tell when and if I get an answer from him, a statement, or whatsoever. I'm just a random dude. He's not. So let's see. This might be interesting. Despite, actually, I don't think he ever will respond. But I'm always in for surprises. I don't know everything. Yeah, that's some screenshot I took. Sadhguru. The moment you realize, I don't know, the longing, the seeking, and the possibility of knowing become a living reality. Which implies a huge amount of learning. That's what the whole thing is about. But anyway, now I got to do some things. Thanks. Bye.